At half-life, the number of atomic particles remaining is the initial atomic number divided by 2. That's half of it will be remaining. And the time taken, this time we call it the half-life. If we put this information into the radioactive decay equation, we now get, that's the equation represented by 1, which I've written again. We now have the number remaining replaced by the initial number divided by 2. Then the right hand side of the equation will give you this. Then the time taken is called the half-life. Divide both sides of the equation by the initial number of atomic particles, n sub 0. If we do that, we now have half on the left hand side being equal to e raised to power minus decay constant times half-life. For our knowledge of mass, this will now give us raised to power time constant, decay constant times half-life. I can write it as 2 is equal to exponential product of decay constant and half-life. If I find the log of both sides, we end up getting decay constant times half-life is the natural log of 2. This is 0.693 is equal to decay constant times half-life. Therefore, half-life is equal to 0.693 divided by the decay constant of the element. This is equation 2. The next equation we are going to get will be a combination of 1 and 2, which will help us to solve problems that has to do with radioactive decay. So we know equation 1 to be number of particles remaining equals to the initial number times this. This is our equation 1. We also know the half-life to be equal to 0.693 divided by the decay constant as our equation 2. Now, from equation 2 above, we have decay constant equal to 0.693 divided by the half-life. I'll call this equation 2b. Now, if we put equation 2b into equation 1, substitute equation 2b into equation 1, we now end up getting the number of particles remaining equals to the initial number exponential minus 0.693 divided by the half-life times the time taken. We can rewrite it like this. If I divide both sides by the initial number of atomic particles, then I now have 0.693 divided by half-life times the time taken. Initial number remaining divided by the initial number equals to fraction of atomic particles remaining after decay. The right hand side of the equation, by simple knowledge of mathematics, will give half raised to power total time for decay divided by the half-life. Thus, we have a very important equation that the fraction of the element remaining after decay is equal to half raised to power total time divided by the half-life. This is equation 3, which we will use very soon to solve problems on radioactivity.